From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. This episode of Fragmented is brought to you by Bitrise, where you can build and operate better apps faster. One of the things I wanted to talk to you today about Bitrise was a couple of the coolest features that they have. And we're going to start off with something known as effortless code signing. And what that allows you to do is sign your Android app effortlessly. That means is you can upload your release key store file and add an Android signing step to your workflow, and you're done. And basically what that allows you to do is build and sign your application from Bitrise itself, which is really cool. Now, another feature that's really awesome is unlimited UI tests for free. Bitrise behind the scenes integrates fully with Firebase's TestLab virtual device testing solution. So with one click, you can basically set up a UI test quickly and reliably. You can check the test output, which is going to be of course, the console, the video, screenshots, logs, etc., right there on your builds page. Now, also related to testing is the UI and unit test on one page. So you can view the UI and unit test results conveniently on the test report page. Now, having all those tests put together makes it super easy actually, to quickly analyze your app and identify any of the bugs you have. Now, lastly, of course, one of the last things I wanted to bring up here that's cool about Bitrise is the number of integrations they have is quite amazing. There are over 240 integrations to cover all your Android app needs. You can add them as each individual steps inside of your workflow. So if you have something that you want to integrate with, it's probably highly likely that Bitrise has an integration for them. So if Bitrise is something you're interested in, it's something you would like to kind of get started with, you want to go ahead and check it out. Again, with Bitrise, you can go ahead and build and operate and build better apps faster. If you're interested, you can learn more at go.bitrise.io/fragmented. Again, that's go.bitrise.io/fragmented. On today's episode, we're going to talk about something that's probably a little controversial to some people, and that's Kotlin's not null assertion operator, also known as the Bangbang or double bang operator. If you still don't know what I'm talking about, this is the operator that's 2 exclamation points that you place after a call in some type of object graph where you want to say that, hey Kotlin, I know that you're not going to compile because this is a nullable type, and I'm trying to access something off the nullable type. Therefore, you're basically giving me a compiler warning and an error saying that, you have to do something because this is a nullable type. And I'm positive that I know what I'm doing, so I'm just going to use this, double exclamation, which is the not null assertion operator, bang bang, right here to verify that, that the customer's first name is going to be there. I know it's going to be there. Trust me, I know what I'm doing. Now, my opinion here is that this is a code smell. And there's a reason why that this is a code smell, because one of the things that Kotlin does is it helps, it doesn't insulate you from null pointer exceptions, but what it does do is it requires you to evaluate each and every single instance in which you may encounter a null pointer exception. And the documentation for basically the not null assertion operator has a very clever, and I like this sentence. It says, if you want an NPE, which is null pointer exception, so if you want a null pointer exception, you can have it, but you have to ask for it explicitly, and it doesn't appear out of the blue. Basically what this is saying is, look, Kotlin's going to do its best to prevent you from getting null pointer exceptions, but if you have a nullable type, you basically have to tell Kotlin, look, if you're going to give me a null pointer exception, just throw it at me right here. And so that's kind of the big misconception a lot of people have around Kotlin is that, it won't let you have nulls and you can't have, you're not going to get null pointer exceptions. That's completely false. You can totally get null pointer exceptions through various ways, such as using the non-null assertion operator. But there's other ways you can get it too. Perhaps you're using a deserialization library that perhaps just doesn't set the value. And when it's accessed, it throws a basically, a Kotlin null pointer exception. There's a couple other different ways you can encounter these things, but the one I'd like to focus on today is the not null assertion operator, so the Bangbang. Now, the reason why I feel that this is basically kind of a code smell is because if this is inside of your production code, you're basically retorting back to behavior that's very similar to that of Java. And if you have a string in Java, it could be null. And if you try to access the length property on that string, it could blow up on you and say this is a null pointer exception. And now you have a crash in your application, which can be, a real bummer, especially if it's in production. Now let's kind of get back to the situation of you have maybe a nullable string in Kotlin and you want to get the length of it. And you use Bangbang. And you say, all right, well, I expect that this string is not going to be null and it's going to, I want to get the length of it for whatever reason. Maybe it's the customer's last name. You expect that the last name is greater than 2 characters for whatever reason. And you want to go ahead and check that, but it's nullable for whatever reason. At that point inside of your code, if you have to access that and you are requiring the length to be there, well, then there should be some other checks that are before that to check, hey, is this type not null? So then the compiler can kind of smartly realize, hey, they've already checked to make sure this is not null, and I can continue on processing without having to worry about a null pointer exception. Or if that's not the case, if it should never be null, well, then at that point you kind of have to reevaluate your system as a whole. Is it the input that's going to be null? Is it something coming from an API that's null? What if it's that case? The API says, hey, this could return null, but the app always expects that it's going to be there. Well, at that point, you kind of have some cognitive dissonance between the API and the client application because the client is expecting it to not be null, but the API is sending it null. So how do you kind of deal with these situations? Well, of course, there's different ways you can deal with it. Is if you have control of the API, you ensure that it doesn't come back null. There's ways to do that on the API, whatever your system is for API. If it's Java, Kotlin, Node, Go, or whatever, you can implement that there. However, if you don't own the API, well, then you have to have some type of contingency behind the scenes to make sure that inside of your application, that if this is null, we'll then go ahead and default maybe to an empty string, or we'll default to some other type of value. So these are things that you can kind of turn your nullable types into non-nullable types. And what this ultimately allows you to do is avoid any of the null pointer exceptions in your code. Now, there are a number of articles out there that are written on Medium and various blogs that, sometimes people avoid the non-null assertion operator far too often, and that becomes a code smell of its own. I don't agree with those. The reason why is the only time I would ever find a non-null assertion operator to be used in production code is if for some reason, not even production code, inside of my app, would be inside of the test code. If I've set up test data that I know that is going to be there for a test scenario, I will then use the non-null assertion operator here because I've set the data up. I know it's not going to be null. At that point, if it does fail, well, then my test fails and I need to investigate why my test failed. So that's the only time I consider the non-null assertion operator to be very useful. Now, there's other lint checks and tools out there that can kind of run this analysis on there for you. So if you attempt to push this up to your CI server and this runs as a Gradle, a check, you can say, hey, if it fails this lint check, well, then I want you to go ahead and basically, if you find something that's using the non-null assertion operator, at that point, go ahead and fail the build. I've seen this used with success on various different teams, and I highly recommend it. Now, there are instances where you might have someone might reply to this and say, well, Donn, what if I have a list of data and this data has some, sometimes it can be null, sometimes it's not null. And for whatever reason, I just need to be able to make sure I get the not null items out of there. I mean, don't I kind of have to either cast it as not null or check to see if it's not null through a loop? Do I have to rebuild the list? Well, no, you don't. There's a lot of standard functions inside of the Kotlin library, such as in the collections class, there's a method called map not null. So let's say you have a list of nullable customers, and for whatever reason, these customers can be null. What you can do is you can say list, whatever you say, customer list dot map not null, and then you could perhaps pass in the values of, the customers that you're looking for, that are not null. And what this operator does, and I'm not explaining it that well, is it will then return all of the items that are not null in that list. So let's say you had a list of orders, or a list of customers, and you wanted to retrieve all their orders, and it could be a nullable list of orders and so forth. You can map that into its own list and only get the ones that are not null out of there using map not null, which basically would take a nullable type and then return you back a non-nullable type that you could work with, meaning that you don't have to use the non-null assertion operator. So that's one way to avoid it. Now, another way to avoid having to use the non-null assertion operator is to use the Elvis operator, and that's the : operator. So let's say, for example, you have, again, a nullable string. You don't expect that the customer's first name is ever going to be null. And so what you could do is you could use the Elvis operator, say, hey, if this is null, then if it's not null, go ahead and use a value. Otherwise, if it's null, I want you to perhaps throw a illegal argument exception. Now, of course, this is a runtime exception. This is going to crash your app. So that, encounters a different problem. Hopefully you catch this in QA and testing. Now, every team doesn't agree with that. Some teams I've worked on will just default to crashing because it's an exceptional case. We don't expect that data to be missing. If it is, the app needs to crash. It shouldn't be missing. That means we have a problem upstream that we need to resolve. There's other, schools of thought that say that you should be defensively coding to ensure that if you do have a null, that you have some type of backup. Perhaps you do that instead of throwing in a legal argument exception. You return an empty string, or you return a default value that you expect that you can work with at that point in time. Now, these are all good ways to avoid having to use the non-null assertion operator, because again, all Kotlin is really doing for you, it's not preventing you from making or obtaining null pointer exceptions. It's making you think about them and how should you handle them, because the compiler is not going to compile. It's going to say, hey, Donn, this is nullable. You're trying to access a property on this nullable type, and we're not going to allow you to do that until you tell us what you would like to do with it. Of course, if you use the non-null assertion operator, you're saying, Kotlin, don't worry about it. I'm smart. I know what I'm doing. Just trust me on this one, man. I got you. And it says, hey, you're the boss. And if things blow up, they blow up, and it's your fault, not ours. So that's what I'm trying to tell you here. Just try to avoid that. Anytime you're using the double bang operator, the non-null assertion operator, they're all the same thing. 2 exclamation points inside of your Kotlin code. Rethink it, how can I do this? Can I use the Elvis operator here? Is there a way for me to, if it's a list, can I map to a not null? So using map not null. Is there a way that I can get some type of value as a default here so I don't have to use this non-null assertion operator? And that's what I'd like to leave with you today. Anytime you find yourself using that operator, 2 exclamation points in a row, stop and think about it. Is there a way that I can avoid using this? Now, the only caveat I'll leave you with is, if it's in test code, I find it okay because I'm setting up my test environment as the way I would like to use it. And the data is the way I expect it to be, so I know that it's not going to be null. So again, just to recap, if you find yourself using the non-null assertion operator, again, that's 2 exclamation points in a row, stop, evaluate it, and think about, is there a way that I can remove this in kind of code with some more Kotlin idiomatic syntax, maybe using an Elvis operator, a default value, maybe throwing an illegal argument exception, maybe mapping, etc. Stop, think about it, and let me know what you think. Thanks for listening. Before we get going here, I want to say one quick thing about our sponsor, Bitrise. With Bitrise, you can build and operate better apps faster. We mentioned a couple of things at the beginning of the episode, and I'll just quickly cover them here. You can have effortless code signing. Upload your key store, get your application signed. You can run unlimited UI tests for free with Firebase Test Lab's virtual device testing solution that's integrated in. You can take those tests and, along with your unit test reports, view all the results on one page, which makes it super convenient and easy to analyze your application. And of course, there's an insane number of integrations where you can integrate Bitrise with any of the tools that you use in your current workflow. If Bitrise is something you're interested in, please go to go.bitrise.io/fragmented. Again, that's go.bitrise.io/fragmented. Thanks, Bitrise.
That's it for the show, folks. Fragmented is hosted by Donn and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.